Okay, this lab is to configure basic PPP with authentication configuration on the serial link. Okay, by default, Cisco serial link are basically using the HDFC encapsulation, which is a proprietary encapsulation, which is not compatible with other brands of router. So if you are connecting Cisco router with other brands of router through the serial link, you should actually change the encapsulation to become PPP. Okay. So before I start our configuration, for the basic configuration, we're going to leave it until the end. So we're going to actually start making sure all the IP addresses are configured, followed by configuring the dynamic routing protocol, which is OSPF, as well as to configure default static route as given in the requirement here. Okay, and last but not least, to change the encapsulation for the serial link between the router. So let's start by going to PCA. Okay, so PCA router 192.168.1.3 as given in the requirement here. 192.168.1.1 for the gateway. Let's save it. PCC, same thing. 192.168.3.3 and for gateway 192.168.3.1. Okay, let's save it also. Okay, so I configure the IP addresses on the PC. So from topology, you can see that most of the links are green except the serial interface between central and branch 1. Okay, so definitely there may be some issue. So let's go and double check and also to make sure that all the IP address given here are being configured appropriately. So click here, CLI, enable config key to show IP interface brief. As I mentioned, this is the best command to actually verify your configuration. So currently I can see that for branch 1, I have my gigabit 01 interface 192.168.1.1, which is status up, protocol up, so it's working. The serial interface 0.10.1.1 interface up and up. So branch 1 is not giving me an issue. Let's double check on central to show IP interface brief. Same thing again. So I can see that my serial interface S000.1.1.1.1 up and up, 0.001 10.2, but the status is down. Protocol is down, so something is wrong with the link. But in IP address is there. So later we go and check the other router before we make a confirmation what is wrong. And the loopback 0 interface 0.9.165.200.225. So everything seems okay for central at the moment, except for the interface that is down. So this is for branch 3. So for branch 3, I can see my gigabit 01 interface is up with the correct address, but the 0.001, the status is administratively down. It means that the interface has not been issued a no shut. So let's do that now. No shut. So good news. Once you have done a no shut, you can see that the link actually becomes green. So for the requirement number 8, configure IP address. We've actually fulfilled the requirement. So for clock rate, if you need to configure, basically you just need to go to the serial interface. And since the clock rate for here is 128,000, so basically the command is just clock rate 128 000. That's it. It's a very easy command to configure. If you need a specific clock rate on your serial interface. So the next is to configure your OSL routing protocol process. So before we configure this, let's look at the requirement in detail. So I'm supposed to configure OSPF using process ID 1 for all the routers, but you are not going to include the 209.165.200.224 network in OSPF process. So it means that later on you're not going to advertise or share this network with the other router. And just now from viewing all the IP addresses on the interface, we know that this network actually is found on central. So central by right, I'm going to share 3 network because of the 3 interface, but I'm not going to share the LO0 interface. Okay, because you can see that I'm going to do a default static route to the LO0 network later. Okay, so it means that for today's network, you can actually draw a line. The below part is actually running OSPF, whereas the above part is actually running a static route, which in this case will be a default static route. So that basically is what we're going to understand at this point in time. So let's go to branch 1. So I think the best command to actually help you when you're configuring your OSPF or any dynamic random call is to do your show IP route, and either you make use of the C or L. For today, we're going to make use of the C, which is the connected destination network entry to help us in our configuration. So we're going to do router OSPF 1, then network, then .1.1.0, slash 30.0.0.0.3 for the wildcard mask, followed by area 0 because we are doing a single area. Next one, network 192.168.1.0, 0.0.0.255, area 0, for the second network. And because there is an interface that is not connected to another router, we want to do the passive interface command for the gigabit 0/1 interface to to ensure maximum usage of the bandwidth. So you can see here, this is making use of this line, and this is making use of this line. So we have completed the OSPF configuration for branch 1. Next, we're going to go to central. So for central, same thing. Let's do a do show IP route command. So you can see we have 3 different networks. But as mentioned, we are not going to include the do 09.165.200.224 network in the OSPF process. So router OSPF 1 network 10.1.1.0, 0.0.0.3, area 0. That will be for the first network. Second one, 10.2.2.0, 0.0.0.3 again, wildcard mask for /30, area 0. No passive interface command required here because there is no interface that is connected to any switch or PC. So this will be what we have now for the first C and the second C. We are not going to include this because this is going to be a default route later to be shared with branch 1 and branch 3. So let's close this now and let's open the branch 3. So branch 3, same thing again, to show IP route, router OSPF 1, network 10.2.2.0, 0.0.0.3, area 0. Network 192.168.3.0, 0.0.0.255 for the wildcard mask for /24, area 0. Passive interface because there's gigabit 0/1 is not connected to another router. So that will be what we're having. If you want to verify your configuration, you can do a do show IP protocol command to verify your process ID is correct, your network that you want to advertise is correct, whether you have configured any passive interface. So once you have configured this, if you were to do a do show IP route command on the router, you will start to see that the router has the O entry, which is network that is shared by, for example, this is branch 1. So I will see network that is shared by central as well as branch 3. So you'll find that if you go to PC A and try to ping your PCC 192.168.3.3, okay, you will find that you'll be successful, okay, because of the network has already been shared. The first time request time is normal, okay, but if you were to try to ping the loopback interface on central, you will find that it will fail. Okay, the reason is because we haven't configured the router to share the route with, okay, branch 1 and branch 3. Okay, you can see just now from here, there is no route pointing to 209.165.200.225. Okay, so as mentioned here, we are supposed to configure default route to point to the loopback interface. Okay, so basically I'm going to do a IP route. Okay, and good news, once you know that it's a default route, it will be 0.0.0.0 followed by 0.0.0.0. And good news, it says using loop LO0 as a local loop interface. So basically it's LO0, okay, for the exit, local exit interface. So basically after you've done this, if you do show IP route again, okay, you will see your default static route appear, which is this line. Okay, S as the read means that it's a default static route and it's pointing to your loopback 0 interface, which is the 209 network. Okay, but if you were to go to branch 1 and do a show IP route again, we still can't see 209 network, okay, or any default route that is pointing to central 209 network. Okay, so there is a way, okay, for dynamic route to actually share the default route, okay, with the rest of the router. So we need to go back to router OSPF 1, okay, and the command basically is default information originate. Okay, this command in the OSPF routing process allows OSPF to share a default route on the router if it has, okay, with other routers. So you press enter, that's it. Okay, so if you go back to branch 1 again and do a show IP route, okay, you will find, okay, that now there is a new entry in the routing table which have an asterisk, and the reason why is O because the default route, which is all 0, are actually shared through the OSPF process. So it means that now branch 1 know how to use the default route to reach, okay, the 209 network. Okay, so let's try out now. You can see that there's a reply now. So now we have ensured that all our network are reachable. Okay, that means that we have actually fulfilled my requirement 13. The last but not least is to configure, to change the encapsulation as well as enable authentication for the serial link between the routers. Okay, so let's do it on branch 1 first. So before we do that, let's just do a do show interface 000, okay, to see what kind of encapsulation the interface is using, which I mentioned just now. The default encapsulation is actually HDLC. So by doing this command, I know that this router serial link is now using HDLC, and I mentioned that Cisco HDLC encapsulation is actually pipe 3. It's not, okay, it's not able to actually work with other brands of router. So we need to change it to an open source encapsulation, which is PPP. Okay, so go to the interface. Okay, and how to change the encapsulation? Basically, you just do encap PPP. Okay, and because we are going to authenticate the link so that it is not anyhow being used by other link, as mentioned here, we're going to enable CHAP authentication. So it'll be PPP authentication CHAP. Okay, so definitely authentication needs some password verification. So you can see that this is good. So in order to verify the correct person communicating with you, okay, for Cisco router, okay, you will need to actually create a username. And for the username, you're going to actually use cap sensitive, the host name of the other router that you want it to be connected. And last but not least, definitely the Cisco password, which is used for the authentication process. So the username will always be pointing to the other routers that you want to be connected. Okay, you can see that once you actually change the encapsulation, and if the other end the encryption is still not changed, your OSPF process will actually goes down. which is normal. Okay, so anyway, let's go to central now and do the same thing, okay, for both the serial interface to branch 1 and branch 3. Okay, so let's go to 0000 now. Okay, and same thing, encapsulation PPP, PPP or authentication CHAP. Okay, and we're going to create username with the username being the host name of branch 1 and the password as given is Cisco. Okay, same thing for serial interface 001, encapsulation PPP, PPP authentication CHAP, and the username pointing to branch 3. Okay, with the password Cisco. Okay, so that will be for the 2 interface. And last but not least, let's go to branch 3. Do the same thing, interface S001, encapsulation PPP, PPP authentication CHAP, and username central, password Cisco. Okay, so that's it. Okay, basically, okay, that will be how you change the encapsulation for all the serial interface on the router itself. Okay. Okay, so you must wait a while because the serial link will take a while to go up, as well as it takes a while for the OSPF to actually start sharing advertising the network. But you can actually press the fast forward button to actually escalate the process. Okay, so let's just double check on all the serial link now to show interface S000 for branch 1. So you can see that now, okay, my encapsulation is no longer HDLC but is PPP. Okay, and to ensure that the router is now working as per normal, let's do a show IP route to ensure that you still get the same, okay, routing table as you see earlier. Okay, because just now the interface actually goes down, so your routing table will actually goes back to square one without all the OSPF route that is being shared. Okay, so to ensure that everything is working, same thing, you can use your PCA to ping PCC. Yes, there's a reply. And ping, okay, loopback 0 interface on central. Okay, so once there's a reply, it means that all your encapsulation has been done properly. Okay, so last but not least, let's do the default basic configuration. Okay, so let's open a notepad. Okay, so that easier for us to do the thing. So no IP domain lookup for the first one. Configure device name already configure, so now do that. Serve pass to encrypt all password. Okay, and banner MOTD to configure message of the day. So where's the message? Let's just copy here. Okay, hex. Okay, so we're going to configure the encrypted previous executive password as class. ENAPLE SECRET CLASS. Okay, we're going to configure the line console 0. Password is Cisco. Okay, we're going to prevent system message interrupt. So login synchronous, login exclamation mark, line VTY 015, password Cisco, LOGING SYNC, login again. Okay, and basically that's it for all the basic configuration. So copy, Control C. Okay, let's go back to the router. Paste. Okay, that's it. Central. Paste. That's it. And branch 3. Paste. That's it. Okay, so let's just check. Okay, 92%. What is it? Okay, it's a banner MOTD you haven't saved. So just ignore banner MOTD. Basically, sometimes it's cap sensitive. Okay, but the last is to save the complication. So let's save the complication to make it more complete. To copy, run, start, enter. To copy, run, start, enter. To copy, run, start, enter. Okay, so if you look back at the activity again, it goes up. Okay, so the only thing that's outstanding is the abnormality, then you can safely ignore. So basically that will conclude the demonstration for this lab.